Hey all, uh, let's solve this famous Leetcode problem today, which says edit distance. Let me check when is the last time I solved. It was September, so it was a year. Let's see whether we can come up with the right approach and tackle this problem. Let me reset the timer and start the stopwatch. Let's go. 2 words, word 1, word 2, minimum number of operations to convert word 1 to word 2, 3 operation, insert a character, delete a character, replace a character. So let me frame it in a simple terms. You are given one word, word 1, and another word, word 2. You can perform 3 operations in the word 1. You can insert any character in word 1. You can delete any character in word 1 or replace any character in word 1 so that word will become word 2. Let me check the constraints. Word can have up to 500 characters. They just have lowercase English letters, so this is good for us, not much tensions. So 3 ops: delete, replace, add. Now we have word 1, suppose horse, word 2, ROS. To make word 1 to word 2, what is the first thing you will think about? Obviously, word 1 is having more characters than word 2, so you must remove few characters. Now you need to decide which characters to be removed so that you will have minimum number of operations. Is H available in the word 2? No. Remove H. Is E available at word 2? No. Remove E. Now we have ORS. And word 2 is ROS. Are they both equal? No, they are not. Because in the place of O we are having R. In the place of R we are having O. Replace O with R with O. It takes 2 operations. It becomes ROS. Now they both are equal. Right? Now total number of operation: 1 to remove H, 1 to remove E, and 2 to replace O and R. 4 number of operations. Is this the only way to do that? No, you can do any number of ways, but this is the way. Replace H with R and R with S. This is not the optimal way. There is more easier way. You can replace H with R and O is equals to O and R with S. Now you don't need to replace R with S. You just need to remove R and E. S is already there. So this is the most optimal way to do this. Now forget about all these things, optimal and all these things. Once when you look at word 1, how do you decide that this is the way which gives you minimum number of operations? By trying all the possible removals, deletes and adds, right? Now if you are too greedy, suppose you are the person who wants to do less work, then what you will do? if word 1 has less number of characters than word 2, you skip add. Why do you need to add any number of characters if it already has more number of characters, right? Word 1 length greater than word 2, I'm sorry, equals to word 2. I'm greedy person, I'll skip add, right? If word 1 length less than word 2, I don't have any other way, I must do add. After adding, if there are any replace, I'll do that. Here I'll skip delete. Here I'll say replace if needed, skip add. Same here, delete if needed, skip add if needed, skip delete, replace or delete. Yeah, these are the two things that comes to your mind. So now we have 2 pointers, I which is pointing towards word 1 and j which is pointing towards word 2. Now if word 1 of I equals to word 1 of I is equals to word 2 of j, then do you need to do any operation? No. Why do you need to do any operation if it is equals? Why do you want to increase total number of operation? If I equals to j, just say I need to check next character of word 1 and next character of word 2, right? Now if it is not equals to j, if I is not equals to j, now what is the key thing that you need to check? As we have told here, if word 1 length is less, here if word 1 length is less, just add it. You don't need to worry about anything. If you want, you can replace it, but add is the better operation in my opinion, because that character might be useful somewhere else. If word 1 length is less than word 2, just add, don't worry about it. Else if word 1 length is greater than or equals to word 2, another thing, word 1 length equals to word 2, we can't delete it, we just replace. If else, if word length is greater than word 2, do you need to worry about that character? Think. I mean, in future it can be used, but still if we replace here, there might be one operation there also, so just delete. So in this way, for every I equals to j, if it equals, we are considering I plus 1 and j plus 1. If I is not equals to j and word 1 length is less than word 2, just add, else delete. Now this might sound stupid, because if you look HORSC and ROS, if we delete H because word 1 length is more than word 2, we don't get minimum number of characters, right? So we need to do both operations, delete or replace. Here we can't just delete it. Suppose if I delete h, o will be the first element and you need to replace o later, which does not give us minimum number of count. At the end, if j will become length of word, then yeah, we achieved what we need. That is, we have made word 1 to word 2. If I does not reach n-1, then we don't need characters towards right, we just delete them. So all these characters n-1 minus I plus 1, this must be added to result at the end, right? Now doing this delete or replace operation, do you think what do you think the complexity of it would be? So if I is not equals to j, you are doing delete and replace. Suppose I equals to 0, j equals to 0, and word 1 dot length greater than word 2. We have two operations every time. We either delete, we either replace. So in the worst case, if word 1 dot length is greater than word 2 and no character is equals to word 2, you must either delete or replace. You delete or replace. So it would be O of 2 power len of word 1. This would be the complexity in the worst case, right? Now for the given length 2 power 500, do you think it is optimal? Nah, it is not. 2 power 500 is too large number. I think you can't even count it in the calculator. Now let me think whether we can optimize this. So here we have two things, I and j pointers. After delete or replace, do you think we reach at a point there is repetitive pattern? Let's not make assumptions, let's check. And 0, 0, we have delete operation, we go 1, 0, and replace operation, we go 1, 0, 1, 1. Yeah. Now again 1, 0 could be delete or replace. I'm trying to draw it as a tree. So yeah. I'm trying to make it a tree. So now 1, 0 again has two operation, delete or replace. If we replace, it will become 1, 1. Now if you see in the first operation, if we replace, we have reached the state 1, 1. In the other operation, we have deleted it first and then replaced. Still we came to the position 1, 1. Now do we need to check for 1, 1 again? No, because we have already reached that state and we have continuing operation from there. Now how do you ensure that this state I comma j is not uh, I mean, you don't solve the state I comma j multiple times. You try to catch it. Catch. This is like if an operation has frequent fetches, catching is best practice in programming. Keep this in your mind. So now how do you catch? In TS attempts we memorize the value at I comma j position, right? Once we have solved the position at 1 comma 0, we'll say that we have already solved this 1 comma 0 and we have value. So if anytime in future we are coming with the same value, instead of doing the logic again, we just check the memory before. If it is in the memory, if I comma j is in the memory, we just return that value, right? Simple. Now what is the complexity? Now the complexity is of you traverse all the characters in the word 1 and all the characters in the word 2. For every word 1, in the worst case, you traverse all the characters in word 2. Got it? Now what is the space? We need to memorize all the index at word 1 and index at word 2. So it would be n star m. Now this is the case. This is where you understand why. Now this is the place where you need to understand data structures. Now from the memorization, to make this better, what is the way? And in the reason why we need to do optimization from here memorization to TP is simple. Let me explain in simple terms. Memorization, you just have a function, you traverse I comma j value, you check memory. If it is in memory, you just return, else you do calculation. It gives the complexity of n cross m. But doing the recursive calls is more like suppose in programming terms we are having stacks. So every time you call a function, it takes some stack memory. In this way, here even though you are storing it in a memory, you are calling that function to get that value. So you are unnecessarily using that stack space. So to avoid this stack space, we have that approach called bottom up dynamic programming. So this is also called tabulation approach. So here you don't say that hey, call that function. You decide that before you do some logic, these are the base conditions I have. Every time I traverse, I'll derive from the base conditions and I'll update. So it is simple. Like you are trying to solve some big problem and you can't solve that big problem every time, and you can't go and see the problem statement every day to solve it. So what you do, you have the base plan. Based on the plan, you are having some task. So every day you come and solve that particular task using the knowledge of previous tasks. That's how bottom-up DP work. So you start with the fundamentals, which is the bottom, and you learn eventually till you reach the goal. This is why we need bottom-up dynamic programming. Here, what is the advantage? Here we don't have any stack space. For memorization, we have stack space of O of n. Here the time and space complexity will be the same except the stack space. The stack space will become O of 1. Right? Now let's see how we can implement dynamic programming and what will be the base conditions. Now what will be the base conditions? When we don't take any character, that is I equals to 0 and j equals to 0, then what is the number of ways? It is single way. Both are equal, right? Now you have three things from the base condition. You either replace. If you replace, it would be I plus 1 and j plus 1. We move one step in the both add. Okay. When you add, what happens? The word 1 index will be the same, but you move word 2 index. This is add. What happens in the delete? You just increment the word 1 index, but word 2 index says the same. Delete. Now think in a bottom up approach. What will, first suppose if you want to reach I comma j, what are the possible ways? If you want to reach I comma j, you either need to replace from I minus 1 and j minus 1. You either need to add from I comma j minus 1. You either need to delete from I minus 1 and j. Now you have three types of operation and you take minimum of these three operation. For current index I comma j, you can take minimum of add, delete and replace. Now when can you do this? When both words are not same. When word of I is not equals to word of j. When it is equals, what is the key thing you have? You just need to go forward. In going forward, let me think in terms of equal. So when I is equals to 0, that is, if you want word 1, you cannot do replace operation before. If you want 0 index at word 1, you cannot do 0th replace operation. You cannot do delete operation because this is the first thing you are doing. So you can, the only possible way to stay at I equals to 0 even after that doing is if you only add an element before. Similarly, if you want to stay at word j at 0th index in word 2, the only possible way you have is you can either you can only delete character from word 1, then the jth pointer stays at 0. Yeah. Now, yes sir, let's go into the implementation. If I equals to 0, you don't need any operation, you just have the same thing, 0 operations. Int n equals to word1 dot size, int m is equals to word2 dot size. Now we need a bottom up tabular dp, vector of int comma vector of int dp of vector of int. What would be the number of columns? That is word2 dot length m plus 1 comma 0. Why we are taking m plus 1 here? Because we need an extra variable to hold the base case. Do we need an extra variable here? Let me think. No, we don't need. Yes. Now we need to traverse all the characters in word1, all the characters in word2, j less than n, j plus plus. If it is 0th index and 0th index, we just have only one way. dp of I comma j. To achieve the 0th index, it is not possible. We can't do any other operation to get here. Let's see if I equals to 0. If I need to stay at 0, we just need to do add operation, which is we can only add dp of I minus 1 comma j. Yes. Let's see if j is equals to 0. To achieve at 0th word, we can only do delete operation, so we just need to consider all the previous operations of delete. Now if we don't want to stay at 0th character and we want to progress, what is the case? Here if here we just continue. Okay. Just continue. No need of continue, right? It's here we are having two variations if the words are equal. If word 1 of I equals to word 2 of j, else if both are equal, no operation, we just copy the previous operations till we can reach left of word 1 and word 2, right? If it is not equals, now we need one operation to do something, and we need to check that one operation from delete or replace or add, which gives minimum. So we check replace, delete, comma, add, -1 j. Yeah. Now at the end, by the time we reach m-1 and -1, we'll be having minimum number of operations. Oh shit, I haven't added. Yes. dp of n का vector and addition of do we need star here? Star. Does C++ support single min? Let me check. What is the issue here? I'm new to C++, so forgive me. If we are having the vector, we do star min element of this works, right? Previous thing is right, we do min for 2 characters. Then where is the issue? Addition of unsigned offset. stl vector dot h. Where is the issue? Oh, I'm doing reverse operation here. I need to do, why this came into picture? I need to do add when it is 0 and delete when j is equals to 0, right? This is the mistake. There is, what am I doing? Equals to 0 j minus 1. Yes. Not add, just assign. Let me assign and check, since it will be always 0. No, this is not issue at all. Is the issue I'm doing? I'm thinking about it. If it is at 0, wait, I'm missing something here. If I comma j to reach word I and j operations, to reach word I and word 2 should be at 0. Oh, we need I operations to reach word I. Okay, so now we need base conditions here. We can't do it without base conditions. I equals to 0 and j equals to 0, it will be 0. To reach I, to reach j when to reach j when I equals to 0 will be j operations. To reach j when, to reach I when j equals to 0, it will be I operations. Now we need to go till n. Also this must be till m, not n. Let's go. And here n comma m, not n minus 1 and m. Let's go. Oh, till there is some issue. Oh, here I is one character and j, right? Yeah, let me submit this. So now for the bottom up DP, the complexity is O of n star m and n star m. Here we are avoiding stack space. Is there any way still we can optimize complexity? So since we need to traverse all the characters in word 1 and word 2, we can never optimize time from n star m. So we need to check if we can optimize space from n star m. If you look at this given way, for the current task we are only depending upon previous so in, like, we are having tasks, and in subtask, in each task we are having subtask. So for the current task and current subtask, we depend upon previous task and current subtask previous. So let me not confuse you. We are having task 1 and task 2. Task 1 is completed and it has subtask T1, T11, T12, so on. Now we had in task 2 we are having subtask again. In the subtasks of task 2 we depend upon task 1 subtasks and task 2 previous subtasks which are already done. So do we need to care about any task completed before previous task? No, we don't need. So we'll be having only previous we need previous and current task. So we can go from O of n star m to O of n plus n. Is there any better way? Do we need two arrays to do that? I minus 1 and j minus 1 we need, I and j minus 1 we need, and I minus 1 and j we need. Can we make it O of n? Let me think. No, since we depend upon subtask in the above task and subtask in the current task which are completed, we can never make it a single array, single task. So this is the maximum we can optimize the space. So what is the final way? It is O of n star m and O of m. This is the optimal complexity. I am not writing that code here since it is already a lot of time taken to come to this approach. You can look at blogs. If you are able to understand why we are optimizing it, that's good enough. So bye.